Hello, you're welcome back. So we'll continue from where we stop. Now we are going to be looking at partial variation. Okay. So now a partial variation is a variation in which a quantity is partly varies with two other quantities. So, uh, for example, we have quantity A partly varies with B and also partly varies with C. Now the question is, what's the difference between partial variation and joint variation? Now in joint variation, okay, we use multiplication to connect the two variation, and of course the constant we use is just one constant for the two variation. Let me actually, okay, for joint variation, let's say A varies jointly with B, and at the same time A varies jointly with C. Okay, so for us to actually connect the two variation, we simply say that A varies, okay, both with varies with B and C times C. So I use multiplication sign, and of course the constant I'm going to introduce, okay, is going to be just one constant for the two variation, but that is not what we have in partial variation. Okay, so when A partly varies with B, then of course and A partly varies with C. So I'm going to actually create a relationship for these three variables, okay, by introducing two constants. One constant is a constant, okay, that is actually that is the coefficient of B, and a constant K1, and the other constant is a constant which of course is a coefficient of C. So it simply means that it's like when you connect A varies with okay, B, and at the same time A varies with C. Okay, so to connect this now, this will have its own constant K1, all right, then multiply by B, then plus this also will have its own constant K2. So, and I'm using plus, not multiplication, so know the difference. All right, I think it will make sense if I actually look at example. Now I have a question. Okay, it goes this way. I'll just read up the question. Y varies partly as the square of x. So okay, let me read it to the end. Y varies as this varies partly as the square of x. Okay, y varies partly as the square of x, and y varies partly as the inverse of square root of x. So let me create that relationship. So that means y varies partly as the square of x. That is, y is going to be k1 x, and at the same time the same y, okay, varies partly as the inverse the square root of x. So that would be for k2, okay, inverse the square root. So when we are looking at inverse now, that's k2 divided by the square root of x, because inverse variation has deals with, okay, division, okay, or reciprocal. So now I have two constants now, k1 and k2. I've created my relationship. Okay, so now let's now go to, we need to get those two constants. The question is to write down the expression for y. Okay, write down the expression for y if y equal to 2 and s equal to 1 and y equal to 6. Okay, when s is equal to 4. Okay, let me read that again. Write down the expression for y if y equal to 2 when s is equal to 1. First of all, I need to get my constant. Okay, so first of all, y is equal to 2. I put that down. I'm having two constants, and then definitely I will have to solve this using simultaneous equation. Okay, let's go there. Y equal to 2, s is equal to 1. If y is equal to 2, s is equal to 1, so I'm going to have y equal to 2, s is equal to 1. That's 1 times k1, which of course is k1. Then plus the same thing happens here, k2, then divided by the square root of k1. The square root of 1, okay? Square root of 1 is 1, and k2 divided by 1 will still give me k2. So I have this to be my equation 1. Remember, I have two constants now, so I'll have to find those two constants. I will need two equations. Okay, so now let's go to, I need another expression. So, and y is equal to 6. When y is equal to 6, s is equal to 4. So that's going to be another equation. So when y is equal to 6, okay, x is equal to 4, that is going to be 4k1, right? Then plus k2, of course, divided by the square root of 4. The square root of 4 is 2. That's going to be my equation 2. So I need to solve this equation to get my k1 and k2, right? So I will, let me use substitution method. All right, from equation 1. From equation 1. Okay, let me make k1 the subject. From equation 1, I have that k1 is going to be equal to 2. I take k2 to the other side. Okay, that's going to be 2 minus k2, right? So all I just need to do is to substitute. Substitute k being equal to 2 minus k2. And what will I will substitute it into equation 2. Equation 2. So now, so I go to equation 2. So any place I see k1 in equation 2, I put 2 minus k2. So equation 2 is 6, then equal to 4 k1, which already we've okay established to be 2 minus k2. Okay, then plus k2, then divided by 4, divided by 2. All right, so I need to now find k2. Now how do I do that? I have to multiply through by 2. Okay, this is a linear equation that has fraction, so I multiply through by the denominator of this fraction. So I have to multiply 6 by 2. Okay, of course that will give me 12. Multiply 4 by 2, that's going to be 8. 2 minus k2. Okay, then of course if I multiply this by 2, 2 divides 2, so I'm left with k2. So I can now open the bracket. So I'm having 12 now, going to be equal to 8 times 2 is 16. Then minus 8k2, right? Then plus k2. All right. Minus 8k2 plus k2, that's going to give me 7k2. Okay. So I'm going to rearrange this equation. I have minus 7k2. So I'll take the minus 7k2 to the other side of the equation. Okay. It becomes plus 7k2, right? So 16 now, because I'm collecting all items. I'll take 12 to this other side. It becomes minus 12. All right. So let me finalize my answer at this other point. So k2 now is going to be equal to 16 minus 12. That gives me 4, right? So that's going to be 4 minus 7. 4 divided by 7, that's my k2. So for me to get k1 now, I'll get k1 from this relationship. So invariably now my k1 is going to be equal to 2 minus k2, which of course is 4 all over 2. Okay, 4 all over 7. Okay, k2 is 4 all over 7. All right, then of course there's already 2 in the denominator times 2. So of course 4 divided by 2, that I'm having 2, so I'm having 2 minus 2 all over 7. So now I have to simplify this fraction. Okay, let's do cross product. 7 times 2 is 14. All right, then 1 times 2 is 2 divided by 7. All right, so this is of course k1. Okay, so now my k1 now is going to be 12 divided by 7. So having gotten my k1 and k2 now, I can now establish that relationship. Remember, the relationship is y is equal to k1x, okay, plus k2 the square root of x. So I'm having y is equal to k1, which of course is 12 all over 7x, plus k2, which I have 4 all over 7x. Okay, so if we should simplify LCM of this fraction, or better still, I multiply through, okay, everything by 7. All right, so I'm gonna have 7y equal to 7 times 12 all over 7. 7 cancel 7 now. Okay, I have 12x, then plus the same thing happen here, then plus 4x. So 7y now is gonna be equal to 12x plus 4x. That gives me 16x. Okay, so that's basically how we actually work on partial variation. All right, so that's the relationship between y and x in a partial variation. Okay, so now in this video we're going to be looking at questions. Okay, so we're going to solve a miscellaneous question. Okay, here we go. So I'm gonna just work on some questions. Okay, so I have a question here. It goes this way: y varies directly as w square. So let me put the statement: y varies directly as w square. All right. Okay. Now, when y is 8, w is equal to 2. So if y varies directly as w square, that means y is equal to kw square, right? So of course, you know, the first step is to find my k. K is gonna be equal to y all over w square. Okay, so I have to find that k using the initial value. So the initial value we have when y is equal to 4. When y is equal to 8, pardon me, w is equal to 2. So that's gonna be 4 divided by w, which is 2 raised to power 2. Okay, 2 raised to power 2 is 4. 4 divided by 4 is 1. Okay, having gotten that, now the question is find y when w is equal to 3. So since my k is equal to 1, then my relationship between y and w is that y is going to be equal to 1 times w square. Okay, from this. So we are looking for y according to the question now. Find y when w is equal to 3. So y is going to be equal to, of course, 1 times w. That's going to be 3 square. All right. So my answer is 9. Okay, as simple as that. Let's look at another question. Okay, let me divide this. They're all simple. They're all simple questions. All you just need to do, the first thing you need to do is to find your constant. This one goes like this: if y varies directly as the square root of n, y varies directly as the square root of n. That means invariably now y is equal to k square root of n. Then my k now is going to be equal to y all over the square root of n. Okay, so here we go. K is going to be equal to, let's look at the initial value. Okay, when y is equal to 4, n is equal to 4 also. So y is equal to 4, then n is going to be equal to the square root of 4, which of course is 4 all over 2, which is 2. Okay, so now what are we looking for? So if k is 2 now, that means variably now my y is going to be equal to 2 from the relationship, right? 2 the square root of n. So now we are looking for y. What are we looking for? Find y when n is equal to 1 whole number 7 all over 9. So it's going to be 2 the square root of 1 whole number 7 all over 9. So of course you know very well that I will have to convert this to an improper fraction, right? Okay, so let's do that. 9 times 1 is 9 plus 7. That gives me 16. So I have 16 all over 9. Okay, so that's going to be equal to 2 times the square root of 16 is 4, right? And the square root of 9 is 3. So I'm having 8 all over 3. 2 times 4 is 8. Okay, and this should give me 2 whole number 2 all over 3. Okay, so they're all simple questions. Okay, so okay, is there any other thing I need to? All right, so that is it. Okay, see you in the next video. Thank you.